We're going to look at nth roots and rational exponents. You will need your calculator handy for this particular setup. Now, if I had given you the problem x squared is equal to 16, we've had these types of problems, and if you were asked to solve for x, in order to get rid of this square, we would square root both sides. And then when we square root, the square root and the square would cancel each other out, and we would have x is equal to plus or minus 4. Now remember, when we do the square root, we need the plus or minus because positive 4 times positive 4 is 16, and negative 4 times negative 4 is also 16. So we would have both the positive and negative. Now if I were to ask you to calculate x cubed is equal to 8, you could go to your cheat sheet in your calculator, go to the cubed column, and you would find 8 on your list and figure out that x would have to be 2. Well, if we have to do this algebraically, in order to get rid of a cubed, we do what's called a cubed root. And it looks very similar to a square root, except for we put a little 3 right out here. That's called the index. Now it's not a regular size 3. It's not being multiplied by 3, so it does not look like this. That's 3 times the square root. Cubed root is a little 3 right up there on your radical sign. So to get rid of a cubed, I have to cube root both sides. Well, if you take your calculator and you need to look for the button that looks similar to this. So it's going to have a little variable out front here for your index, and then it'll have another variable inside. It might also have the y out here instead. More than likely it's going to be by your regular square root button that you normally use. So go ahead and find that button on your calculator and then type in the cubed root of 8, and you will find that it'll give you an answer of 2, just like you would have gotten from looking at your cheat sheet. Now for a cubed root, we do not have the plus or minus. The reason for that is that if I take 2 times 2 times 2, that will give me an 8. If I take negative 2 times negative 2 times negative 2, these first two negative 2's will give me a positive 4, and then a positive 4 times negative 2 will give me a negative 8. Well, that's not what I'm looking for here. I want the cubed root of just 8. Okay, we can also do that when we have things to the 4th power. Well, instead of doing the square root or the cubed root, we're going to have to do the 4th root because we need to get rid of that 4th exponent. So I'm going to take the 4th root of both sides. So you can type in the 4th root of 81 and hit equals, and it's going to give you back a 3. Now here you have to be careful though again, because with the 4th root, it's going to be plus or minus. And the reason is identical to this concept right here. So with the 4th root, I have plus minus again. Now jumping over here to x to the 5th. In order to get rid of x to the 5th, I need a 5th root. So I would take the 5th root of both sides. Now my 5th root and my 5th power would cancel each other out. So I would end up having x equals 3. And for x to the 5th power, I'm not going to have two answers, and it's for the same reason that we had on the cubed root one. So our general rule is that if the root is even, so if I have square roots, 4th roots, 6th roots, 8th roots, an even index here, you're going to have the plus minus. If your index is odd, so if you are taking an odd root, so a cubed root, a 5th root, a 7th root, any of those, you're just going to keep the sign of the number. So when I did the cubed root of 8 right here, it was positive 2 because my 8 was positive. When we took the 5th root of 243, it's going to be positive 3 because the 243 is positive. Here's going to be our first set of examples. It says find the nth root for each of the following. Here they tell me n is equal to 6 and a is equal to 215. So what this is really saying is find the 6th root, because I want the nth root of 215. Well, you're going to need your calculator for this one, because you'll notice 215 is not on our cheat sheet. So you would need to type in the 6th root of 215, type that into your calculator, and you're going to get this big, long, ugly decimal. I'm going to go ahead and round it off at 2.448. So that's going to just be an approximation of it. Now with this one, we have the 6th root. So you have to decide, do we need plus or minus, or do we just keep the positive? And if you remember, our rule from before said that if we have an even root, it's plus minus. If we have an odd root, you keep the sign of the number. Well, 6 is an even root. So our actual answer is plus minus 2.448. Even though the calculator only gives you the positive, you have to be thinking about that as you do these problems. Okay, this one wants us to find the 2nd root of 81. Well, you've actually done a ton of these so far. The 2nd root of 81 is really the regular square root that we've been working with. Since square root is our very basic, most common one, it's not customary to put the 2 here, but it's not wrong. So if there is no index, it's really a 2. So it's just regular square root if there's no index. Well, square root of 81, hopefully you know that one, is plus or minus 9. Okay, this next one here wants to have the cubed root of negative 125. So if I set that up, and I can look at my cheat sheet on my cubed root, check to see if 125 is on there, and it is, but negative 125 isn't on there. So for this one, you have to be thinking about your final answer is just going to be negative. So if I look at the cubed root of 125, I see that it's 5. But since I want the cubed root of negative 125, I'm actually going to have an answer of negative 5. So this is an example of where my odd root of 3, my answer matches the sign of my number. So since I had negative 125, my answer was negative 5. Next little bit of this section is dealing with rational exponents. Now if we break down the word rational again, the root word of it is ratio, and ratio means fraction. So we're going to be changing these radicals into exponents that are fractions. What we're going to be doing is your index slides over and becomes the denominator. So if I were to have the cubed root of x squared, I could rewrite that as a rational exponent and write it as x to the 2/3 power. So see this rational part, the ratio is the 2/3 and it's my exponent. So now I have x to the 2/3 power. These two statements are equivalent. They're the exact same thing. What you'll find is that you'll be using rational exponents in upcoming sections, so you want to make sure that you're comfortable changing them. Here's another one. If I have the 5th root of mn raised to the 7th, that means I have mn, make sure I leave them as a group for right now because the whole thing is under the radical. The 5 is going to slide over and become the denominator. So it's going to be raised to the 7/5 power. Okay, now we're going to kind of go backwards. D to the 1/2 power. What if I need to write it using a radical symbol? Well, my denominator is going to slide back over and become my index. So I would have 2 the d and then raised to the 1. Well, now remember, the 2 is an index. It's not customary to write it there. It's just a regular square root. So we have the square root of d. And for this particular one, when I raise something to the 1st power, I don't really need it there because it's not an exponent that does anything. So this would actually be another way of writing the square root of d. So d to the 1/2 just means the square root of d. Okay, here's where we're going to start using some of these things. Let's say we need to solve this particular problem. Well, I'm going to follow my algebra steps, so the first thing I have to get rid of is divide by 2. When I do that, I'm going to have x to the 4th is equal to 81. Now, in order to get rid of the 4th power, I need to take the 4th root of both sides. Now, as I'm doing this, I have to remember that I'm applying the fourth root, and the 4 is an even root, so I've got to make sure I do plus or minus. Two options. You can look on your cheat sheet into the fourth column, or to the x to the fourth column, and see if 81's on the list, or you can type it into your calculator and see what you come up with. You will find 81 on the list, and it'll take you over to 3. But now remember, we've got that even root, so I have to make sure I do my answer as plus minus 3. Another one that we are going to solve. I've got 3x to the 5th plus 10 equals negative 17. Still going to follow my regular steps I do for solving equations. I'm going to subtract 10 from both sides. So I'll have 3x to the 5th is equal to negative 27. Divide both sides by 3. And I'm going to have x to the 5th equals negative 9. And now to get rid of this 5th power, I have to undo that by taking the 5th root. So I'm going to take the 5th root of negative 9, and I end up getting x is equal to negative, rounds to about 1.55. So this one you would have had to use your calculator on because it's not on our cheat sheet. So when you type in the 5th root of negative 9, you should get about 1.55. And here's another one for us to solve. Now this one, I can't get to that minus 2 yet because it's inside the parentheses, and I need to get rid of the parentheses first. Well, I can't get rid of the parentheses until I get rid of this exponent. So I need to undo this 3 here, and I do that by taking the cubed root of both sides. Well, when I take this side's cubed root, I'm just left with an x minus 2. And when I take the cubed root of 80, I'm going to get about 4.31. Then I still have to get x by itself, so I have to add 2 to both sides now. And I end up getting x is equal to 6.31, approximately. Now to check these, I can plug them back in to my original equation. Now you have to realize though that this is a rounded answer, so when I plug it back in, it's not going to be a perfect 80, but it's going to be really darn close. Okay, here's our second practice. First one says to rewrite using rational exponent notation. So what that wants us to do is it wants to take this radical symbols and write it as a fractional exponent. So for this one, the 3 is going to slide over and become the denominator of my fraction. Now since the entire part of 2x is under the radical sign, I have to put it in parentheses. So I'm going to end up with that quantity 2x, and we're going to raise that to the 4/3 power. Okay, go ahead and pause the video and see if you can come up with the second one. It says to rewrite using radical notation. Radical notation means using roots. Now you might be looking at this wondering why the 4 isn't part of the radical. And what you have to realize is that this 2/3 is only attached to the c. And the last one, go ahead and pause the video again and see if you can solve this one for x. Go ahead and check your answer by plugging it back in also. Okay, for this one, first thing, hopefully you divided both sides by 3, and you would have had this expression right here. Then you have to do the 5th root because I can't get inside the parentheses until the parentheses are gone, and I can't get rid of them until I get rid of that 5. So I do the 5th root of both sides. Now since it's an odd root, I don't have to have the plus minus here. When I take the 5th root of the left side, the 5th root and the 5th power cancel each other out, so I'm left with 2x plus 5. And then the 5th root of 33 is about 2.012, so that's a rounded decimal again. Then I can finish solving it using algebra. Subtract 5 from both sides, divide by 2, and I got x to be about negative 1.494 or so.